So there are three core concepts behind MCP that I need to explain to you about. First of all is what's known as the MCP host. The MCP host is the overall application in which you're going to be equipping an agent with tools. And so the host could be something like Claude Desktop, the piece of software that runs on your computer that manages Claude, the LLM, and lets you chat with Claude. It could be our agent architecture, a piece of software that we've written using perhaps the OpenAI Agents SDK that's going to run agents and tools. So that overall application, piece of software running this agentic framework, that is known as the host, the MCP host. An MCP client is a small piece of software, think of it like a plugin that runs inside that host, within the host. And each MCP client is going to connect one-to-one with something I'm about to explain called an MCP server. So if you're running Claude Desktop, for example, and you're using a bunch of different MCP servers, then you're going to have a little client, an MCP client running for each of those. So MCP client lives in the host. It connects to the server. The server runs outside the host. So what is this server? The server is the actual piece of code that provides tools and context and prompts, these extra capabilities to your agent. And as I say, tools is the one to really focus on. That's the one that's got the most excitement, but it can also, in addition to equipping an agent with tools, it can also provide extra context for looking up information, and it can provide prompt templates as well. That is something that would happen by the MCP server running outside the host. Now, let me make that concrete by telling you about a particular MCP server called Fetch. So Fetch, then, it's an MCP server that is able to search the internet and fetch a web page. The way it actually does it is kind of cool. It runs a browser. It launches a little browser, a headless browser, like a headless Chrome, as they call it, so that you don't actually see the browser. And it uses Playwright from Microsoft to drive that browser to collect the page and to read its contents and return it. So that is a tool, and it's wrapped in an MCP server, and you can run that MCP server. And then you can configure Claude Desktop, the Claude desktop application, so that within it, it runs an MCP client that connects to that MCP server, so that Claude, if you're chatting with Claude, it's suddenly able to read web pages live. And that's what's happening behind the scenes. And in this case that I'm describing, that MCP server is also running on your computer. You're talking to Claude Desktop. It's able behind the scenes to connect to that MCP server, to run a headless browser, to collect a web page, and then to answer questions based on it. And in fact, we did that. We used the Fetch MCP server already in AutoGen last week. Hopefully you didn't skip last week because it was fun. And we used this very MCP server via AutoGen, and that's what it was doing. And perhaps we'll help clarify this to show you a diagram, an architecture diagram of how this fits together. Imagine this box is representing your computer, your machine, and within your machine, you have a host running. So that host, it could be Claude desktop app. It could be software that we have written as part of this course that's using OpenAI Agents SDK. And we have a couple of MCP servers running on your box. Maybe one of them is something that can connect to the local file system. Maybe one of them is something that can ask for the weather. And within that host, you would have a couple of MCP clients, one MCP client for each of the MCP servers running on your computer. You can also have a remote server. This is an alternative architecture. This is the second way of doing it. And you can have an MCP server running on that remote server, and you can connect to that remote server using an MCP client. But it's important to mention that this is in fact quite rare. This is not the way it's normally done. You hear the word like MCP server and you think, okay, that sounds like something that's like a remote server. And so you imagine it's like the diagram I've just shown you, but it's actually very rare to do it that way. Almost always, in most of the examples that we'll look at, the MCP servers are things that run on your computer. They're running outside the host and you're connecting to it, but it's still running on your machine. Now, you will have retrieved that from somewhere public. So it's been shared by somebody else, but it's been retrieved and installed on your computer. So like when we use the fetch MCP server, it was running on our machine. We were collecting it from actually Anthropic's repository, but we were then running the fetch MCP server on our machine outside the host. And we had a host, which was AutoGen in this case. We'd written some code that acted as the client, and it was connecting to that server running on our computer. So using remote MCP servers is possible. It's a thing, but it's not common. And sometimes these are called hosted MCP servers. Sometimes they're called managed MCP servers, but they're not that common. And so that's a super important misconception and confusion that I really wanted to clarify. The fact that in most cases, MCP servers are things that you install from some remote repo, but it's running on your box. Okay, but it's worth pointing out that there is another configuration here, and that looks like this. The MCP server that you're running in your box, it might be doing something that just involves locally processing on your computer, like it might be writing a file to your file system. But also there are many MCP servers that take advantage of functionality over the internet. The fetch MCP server that we just mentioned, of course, that actually runs a web browser and looks over the internet. You can also get MCP servers that check the weather. And of course, they're doing that by calling some web service. So it's very common to have an MCP server that is connecting online and calling some remote service. In fact, that is by far the most common of the configurations. But it's important in your mind to distinguish between that I've just shown you and a case where your MCP client is calling a remote MCP server hosted on another machine, which is, as I say, less common. So one more time, if I haven't stressed this enough, MCP servers mostly run in your box. You typically download them and you run them locally. And if you're wondering why I'm telling you this 100 times, it's because it really is. People do get very confused about this because the terminology is muddling. But that's the way it works. In fact, as I'll show you when we start looking at MCP marketplaces, there are thousands of MCP servers and they all run in a box. And there's not so many. It's quite hard to find ones. It's quite hard to discover ones that are ones that you could connect to remotely. Now, there are two different technical mechanisms for how MCP servers can work. Two different transport mechanisms, as they're called, in the official Anthropic spec so far. The first of them, which is by far the most common, is called Studio, spelled like that, which stands for Standard Input Output. I think some people call it STDIO, but I call it Studio. This is the simplest approach. And if you're using this approach, then basically your MCP client spawns a process, a separate process on your computer, and it communicates with that process over just standard input and output. And that's why it's called STDIO. And that process is, this is the most common way of doing it, and we'll be exploring this a lot. And when we build our own MCP server, we'll be using this technique. The other technique is called SSE. And SSE, which stands for server-side events, uses a HTTPS connection and it streams back results, much the way that you see stuff streaming back from LLMs when you see the information flowing back. That also uses SSE technology. And if you're going to use one of these remote MCP servers, a hosted or managed MCP server, as in the picture on the top right there, then you need to use SSE. You can't use STDIO for connecting remotely like that. It has to be SSE. If you're using local MCP servers, the common case, then it can be either STDIO, Studio, or SSE, either way. And it's most common to be STDIO. Okay, so take a good look at this, make sure that it's getting clear in your mind. You know the difference in a host, an MCP client, MCP server, the three different arrangements, SSE versus Studio. And now with that, it's time for our lab. Let's go and make use of MCP servers in the fabulous OpenAI Agents SDK. And I'm so happy to welcome you back to Cursor for our epic week 6 finale. So we've got a nice organized collapsed file explorer on the left here. I'm going to open up week 6 and you'll see there's quite a lot going on here. We've got a lot of work to do this week. And we're going to start with the first lab, lab 1. Welcome to week 6. And remember, with these labs, the first thing you need to do is click up here to set the kernel, something which you know back to front by now. So, welcome to the Model Context Protocol. Welcome back, OpenAI Agents SDK, which I may have mentioned just happens to be my favorite. And please do note that as I go through this and you see the code here, it might look different to you as you go through it in the lab. And that's a good thing. That's because I'm constantly updating this. MCP is very much a moving target. It is honestly evolving so quickly. There's new stuff all the time. And I try and keep the labs as up to date as possible. If you haven't done this before, then be sure to pull the latest code. There's instructions how in the guides if you're new to this, to using Git and Git pull. But then make sure you've got the latest and you're good to go. And I need to start with some bad news. Some news for Windows PC people. There is a production problem with MCP. That means that MCP may not work out of the box with Windows PCs. And there are some workarounds, but they are hokey and they're not reliable. And there is only one real proper solution to this, and it's a bit of a bore. You will need to install something called WSL, Windows Subsystem for Linux. And that allows you to run like a Linux operating system on your PC and be running Cursor connected to that. If you do that, MCP will work fabulously. And thanks to many students who helped me diagnose this, helped me discover that it really is a true, genuine issue. There is no way around it, or at least no reliable way around it. And that the proper solution is using WSL that is now well confirmed. So in order to set up WSL, there is setup instructions. I put in setup a whole section on WSL, setup WSL, and it looks like this. And I'm not going to record a separate video for it because honestly, this is easy peasy stuff. It's identical to setting up your environment the first time around. You just have to go through it one more time. And it's just something to hammer through. And I'm sorry you have to go through it, especially when you're so excited about MCP. But at the end of it, it's gonna work. One thing to know about when you're doing this, if you don't already know this, Windows people, that in WSL, you need to be aware of whether you are in the home directory of your Linux system, your Linux home directory, or in the home directory of your PC. And the stuff that you want to work on should be in your Linux home directory. And when you first launch WSL, there's two ways to do it. You can type WSL, or you can type Ubuntu. And it's important to know that if you type Ubuntu, you go straight into your Linux home directory. So that's the safer way to do it. Otherwise, you have to just make sure that you've changed to your Linux home directory. And the instructions are in the setup guide. And for Mac people, you guys are in great shape. You don't need to worry about any of this. This is unfortunately a PC thing. So hopefully by this point, if you're a PC person, you have now installed WSL, you are back here, ready to go, and we're off to the races. And I barely need to tell you that we start with some imports, and we start by importing and loading our .env secrets. Okay, so we're now going to use MCP in OpenAI Agents SDK. We're going to do it by creating an MCP client, have it create a server, and then collect the tools that server is able to use. And we're going to start with fetch, which is the MCP server we looked at last time. That's the one I just yabbed away about that runs a headless browser. So when you're working with MCP servers, everything begins with these things called parameters. Parameters is the way of describing the MCP server. And the parameters look like this. This is the parameters for fetch. It's like a dictionary which contains a bunch of stuff. Now, what is that stuff? That stuff is in fact just something which will be run at the command line that will spawn this MCP server. So it's actually a command. This is the command that needs to run at the command line, and then a bunch of arguments. And if you look at this command, it might look a bit familiar because this command, UVX, basically is a UV, installs and runs a package, a script. And so this is basically essentially doing a UV run. It's running a Python process. And what we'll discover is that many MCP servers are just like this, UVX, and then the name of the repo, the place where it should install something locally and then run it. And so that is what we do with these parameters right here. Okay. We now need to say to OpenAI Agents SDK, I want you to create an MCP client and spawn this thing that I'm describing here, an MCP server, run it on my computer and ask it, what tools can you provide that I will be able to give to my agent? And this could not be easier. It is like one line of code. OpenAI Agents SDK makes it really easy. You use a context manager with, and then MCP server stdio, because this is one of these stdio standard input output types of MCP servers. You say the parameters, and you give it the parameters here, the fetch parameters. This is useful to know. It's worth specifying a timeout. The default timeout is 5 seconds, and that's very hit or miss. Sometimes it times out, which is super annoying. So I always pass in 30 or 60 seconds timeout. And then you can just simply get what comes back from this server and just call list tools. And so again, what this is going to do, it's going to run this command on my computer to spawn a new Python process. That is our MCP server. It's going to create an MCP client running within OpenAI Agents SDK. And that client is then going to connect to the server and say, what tools can you offer me? What can I do with you? And then we're going to print that. And all of that is happening right now and happened in 0.8 seconds. And we got back a tool, and that tool is called Fetch. And it has a description. Fetch is a URL from the internet and optionally extracts its contents as markdown. And then, interesting, there's a bit more here. Although originally you did not have internet access and were advised to refuse and tell the user this tool now grants you internet access. This is super interesting. You can see that the makers of this MCP server have worked hard on the description of the tool, and this is what will be passed to the LLM eventually, to make sure that it's most likely to use this tool properly. And since a lot of LLMs have been trained to say you don't have internet access, the makers of this tool, that's Anthropic, learned that it's good to include in the description something that explains, hey, look, you didn't used to be able to search the internet, but now you can. And it's this kind of stuff, it's this kind of prompt information that's been included in this tool that makes it so valuable. Because if you didn't have this, then you'd have to know to do that. You'd have to understand, if I want to write a tool that searches the internet, I'm going to need to explain to the LLM that it now has this functionality. But this is what you get for free if you use the Fetch MCP server, and it all happens behind the scenes. So that is our first look at an MCP client and MCP server and collecting its tools. Okay, so now we're moving on to another MCP server before we come back and actually put this one to use. So this one was the first one we looked at was an example of a Python-based MCP server that we executed by calling UVX and passing in the name of something that is on PyPy that you could pip install that is able to run. Now, what we're going to do now is use a JavaScript-based MCP server. And whilst Python-based ones you typically run using UVX, JavaScript ones you run using server-side JavaScript, which uses something called Node that I imagine most of you are probably very familiar with, but you may not be. If you're not and you don't have Node installed in your system, then please follow this link to follow ChatGPT's instructions. It is super simple, and installing Node is like what so many people have that. And by the way, you do need to have a recent version of Node. So following this, if you're a Node person already, you've got an older version, then use MVM and make sure that you're on a recent new version of Node. And make sure you can type like npx ---- version and that you get a good recent version. So we're now going to use this to have a Node-based MCP server. So this time, when we specify the parameters, the command we're going to run is not UVX, but it's npx. We're using npm, the Node package manager. And this isn't getting pip installed in the same way as before. This is now using npm. This is coming as an official Node package. And we're using Playwright, Microsoft's Playwright, which is the browser automation software. And this is a particularly popular MCP server that runs with Node using Playwright. Now, you might say to yourself, hang on a second, but isn't the Fetch MCP server that we just didn't you mention that it also uses Playwright behind the scenes? And it's true, it does. But there's a benefit to using this MCP server, which will become very clear to you in just a second. All right, so once we've specified the parameters, we then have exactly the same code construct. We take MCP server, stdio, our context manager, we pass in the parameters. Again, remember this timeout is important to have. And then we call server.list tools again to find the tools that comes from this. And when I run this, it's going to call npx, which is going to then install that package and then call the tools on it. And wowza, this is what we get back. So this is the difference from Fetch. Fetch, we just got one tool. This is actually giving you much more granular control over the playwright process. This is a ton of tools to do things like close the browser, resize the browser, see the console messages, upload a file, press a key, navigate back and forward, take a screenshot, which is super interesting. Drag, click, hover, select. So this is giving fine-grained control over the browser window to our agent, where Fetch was a much simpler MCP server just to collect one web page. So this is pretty exciting. This is opening the ability for us to write agents that can power a browser window, much as our sidekick did in week 4. And now one of the great things about MCP servers is that it's so easy to equip your agent with a whole slew of these. You can just find ones that interest you and just add it in, which is why we're going to go on and do another one. It's going to be another JavaScript-based one, another Node-based one. And so you can see, first of all, I just use this just to quickly get the name of a directory. I'm going to get the name of a directory called Sandbox inside this directory right over there. And if that doesn't already exist for you in your file system, you might need to create that sandbox folder right there, that directory. So I'm going to get that path. And then again, I'm just going to create one of these parameters. The command is npx again to run node. And I'm passing in again the name of something that's an npm that is it's another Anthropic example reference MCP server, and it's called server file system. And it kind of does what you're probably expecting, but we'll make it list its tools again. So now this is again running that node program. The server, it created a client, it spawned the server, it connected to it, it asked for tools, and this is what it got back. It's able to basically read and write from your local file system. It can read a file, read multiple files, create a directory, list directory, and so on, but always within the sandbox path that we specified. So this is allowing you to equip an agent with tools so that it can read and write from your file system, but keeping it isolated to within a certain directory. Okay, so you're probably thinking, all right, Ed, I get it. We can create something that spawns a server and that tells us a bunch of tools, but that doesn't sound much fun. We want it to actually do stuff. And that's what we'll get to right now. So we are now going to make just a quick example of an agent that will use these tools. So here we go. Here are some instructions for our agent. You browse the internet to accomplish your instructions. You're highly capable of browsing the internet independently to accomplish your task, including accepting cookies, clicking not now. If at one website isn't fruitful, try another. Be persistent until you've solved your assignment. So that's a nice set of instructions to prep our MCP server. So we now, again, use this same context manager as before, the one we used to collect the names of tools. We pass in the parameters we want, and again, remember that timeout. And we'll do it for both of our files MCP server, the one that can write to the disk, and the playwright one that can control a browser in a fine-grained way. And we will create an agent, and it is called Investigator. We give it those instructions. We'll give it that model. We might as well, let's change this to be the latest and greatest GPT-4.1 mini. And then look, this is it. You then pass in a collection of MCP servers. You might remember in the past that you could pass in tools directly in here. Well, rather than tools, you can pass in MCP servers, and OpenAI Agents SDK will query these for understanding their tools and provide those capabilities to this investigator agent. And that is as complicated as it gets. That's how we equip our agents to be able to use these tools. And now, if you remember, do you remember the OpenAI Agents SDK? Once you've created the agent, that was step 1. Step 2 is you set up a trace so that we can track this in the UI. And then we call runner.run. And what is the assignment that I'm going to give our agent? I'm going to say, find a great recipe for banoffee pie. then summarize it in Markdown to banoffee.md. And you may be wondering, what on earth is Banoffee Pie? And I think it's a tragedy that you're wondering that. Banoffee Pie, us Brits, we're not well known for our cooking, let's face it. We're not necessarily the purveyors of the great delicacies of the world. But Banoffee Pie is something that I think we invented, and it's really amazing. And I think it's a great shame that more people don't know about it. And so that's why I'm doing you this service by having this be the thing that we are going to have an agent go off and investigate on our behalf. And so with that, let's give this a whirl. Okay, we will run this, and off it goes. And a few seconds go by. Thinks about this request for us. It's spawning these MCP servers, and a browser window has just popped up on my computer. Move it. There we go. So it appears to have gone to bbcgoodfood.com. So it obviously does know that this is something British, and something is happening behind the scenes. It's thinking about this. I can see from the title of this page that it has indeed located a Banoffee Pie recipe. So this is the result of the MCP server running. It is driving Playwright. We don't know everything it's doing behind the scenes, but sometimes you get to see it actually like clicking around and navigating. But I suspect, yes, we will find that it has indeed found a recipe for Banoffee Pie. And from just a quick look at this, I tell you that I'm hopeless at cooking. I can cook nothing. I can hardly cook a boiled egg, but I can cook Banoffee Pie. I know how to cook. I know how to make Banoffee Pie. And from a first glance at this, I think that this probably is a legit version of Banoffee Pie. But most importantly, we need to look in our sandbox and open the preview of this file and confirm that sure enough, it has used the other MCP server. So not only has it used one MCP server to navigate the internet and locate a recipe for Banoffee Pie, but it's also used the other MCP server to then write that to disk. And here it is on my computer. So I would say that is mission accomplished. We have used our first 2 MCP servers. And you probably remember from week 2 what comes next. We want to go and look in OpenAI at our trace so we can see what happened behind the scenes. So go in the usual link, up comes traces, go in to investigate and see what happened. And we'll see that, of course, it listed the MCP tools associated with each of its MCP servers, and it then used the browser navigate tool to be able to navigate the web page. Yours may look different. You may have more action there. And it then used the file tools. For some reason, it did a read file, but then it did the write file to write out the Banoffee Pie recipe in there. And that shows the interactions between the tools. You should look at it, check it's behaving as you expect, check it's using the right tools in the right way. So the aha moment when you realize what makes MCP so exciting is when you first see an MCP marketplace. That's what we're going to do right now. The marketplaces are websites where you can see all the MCP servers that are out there available for you to equip your agent with. And MCP.so is a very popular one, a very common one. Let's go in here. This is launching the MCP.so marketplace. We see a bunch of different MCP servers in their featured list, including the Playwright MCP server that we just used. And if we go into this, we can look at it. We can see that it has the parameters that we use to integrate with it there. You can have a look at the tools that you can call if you use it. You can see it was created by Microsoft, by the way, which gives you a sense that it's probably legit. And look through all of the information about the tools that it can run. And if you press the Explore tab in the main navigation, then you get to see the sort of search and filter. Over here, you can see the different MCP servers in the different categories. And this is where you should get like a wow feeling. There's 4,000 in the research and data category, 68 browser automation, knowledge and memory, equipping your LLM to be able, your agent to be able to remember things in different ways, 34 of them, 19 different calendar managers, and then lots of monitoring, visualization. I think somewhere here is developer. That's the really big category that has tons and tons of MCP servers. But developer tools, here we go, 7,344. So, and I imagine there's some overlap between these categories, but it gives you a sense that there's so much to pick from. There's so much that you can explore here for equipping your agents. And now let's go look at a couple of other marketplaces. So the next link I have here is to Glamour, which is another popular MCP server marketplace. And you come in here and click on the Every MCP Server link, and you get to see the ones on Glamour. And they also have ratings for security, how permissive the licensing is, and the quality. And you can read about how they come up with this. And that's helpful for assessing the security of these. And again, you see the volumes involved, that there's a lot of these out there. Now, security brings up a great point, and there's a lot of concern in the community about the security of MCP servers, because when you run an MCP server, it is running on your computer, running on your box. There's a whole thing about authentication of MCP servers. And again, that's talking more about when you're connecting to a remote MCP server, a hosted or managed MCP server running somewhere else. And then there's ways that you can authenticate with that server. But in this case, and typically most of the time, you're running an MCP server, you're running somebody else's code on your computer. And so at first blush, you might say, okay, that's a real concern. And it is, but it's important to keep something in mind. Ultimately, running these MCP servers, it's like doing a pip install or an npm install. You are installing open source code on your computer, and that is as dangerous as just doing a pip install of someone else's code. That's what you're doing. The open source community, of course, it is something where you are signing up for some information risk that you need to manage. And that means that you need to do your due diligence on the tools that you use, just as you would any package that you pip installed from PyPy. It's exactly the same thing. If it's, of course, a package that's published by Microsoft or Anthropic, then you're probably in good shape. If it's not, then you want to do the usual kind of investigation. You want to check that there's lots of Git stars in the GitHub repo, that there's an active community, and that it has good feedback, and that you are satisfied with the kind of security reviews that have happened for that MCP tool. And so MCP servers are only as safe as any code that you directly download and run on your computer. And you need to be very cognizant of that. Of course, there are some MCP servers that you can configure to run inside a Docker container, and that does give you some extra security controls there. But ultimately, you should always be doing your security review by doing your own research of the publisher of this server and of the information about it, and looking into the code and the repo to satisfy yourself that this is something you want to run. One of the reasons that people are concerned about MCP server security is that people who aren't technologists, people who are just end users, have the ability to add MCP servers to things like Claude Desktop. And that's more worrying because they don't have the same kinds of skills that you and I have. They don't know how to go and track something down in GitHub, make sure it's got a community, make sure that they have a good feeling about the publisher. So when it comes to you and me, we've got this knowledge. We know how to vet packages, open source packages that we install. And so we can do that kind of due diligence. The concern is more where end users are just adding these to Claude and they don't necessarily have those skills. And so that's an important distinction to make. But in addition to that, if you're looking at something like Glamour, then you can look at the ratings that they give it for security, and you can read about the kinds of tests that they carry out that means that they're comfortable giving it the A grade. And you can decide that you're as a starting point, you're only going to take MCP servers that get 3 sets of A's on the Glamour marketplace. So there are several of these marketplaces. One other I wanted to show you is called Smithery, and it is very popular. Lots of people do use Smithery, and you'll notice that you probably see already many familiar MCP servers. Most popular MCP servers are installed in all of the marketplaces. But Smithery also allows you to come in, there's Playwright again from Microsoft, come into here, read about the MCP server itself. You can see the way that you could run it directly from the command line with npx, and you can see by logging in, if I were to log in, I'd be able to get the parameters right there. And you can see things like the tools that it offers as well. Similar to the other marketplaces, Smithery is quite popular. And then I also wanted to point you at a couple of blog posts that I think are really great. This is one that's been posted on Hugging Face that has a bunch of libraries that you can look at, or marketplaces really. And it starts with mcp.so that we already saw and Smithery that we just saw as well. And then there are some more. There are so many to look at. Awesome MCP servers. And Cursor has a directory if you want to integrate MCP servers directly into Cursor to arm your Cursor agent so that it's equipped with this kind of functionality. And many, many more. The official MCP open source project that's hosted by Anthropic has a bunch of the reference servers, including Fetch, one that we looked at, which some of the most robust that you can start with, and Klein for sure. So this is a good resource to look at with some great marketplaces. And then I found this article on Hugging Face as really nicely put, very accurate and thoughtful about, again, what is it that's so great about MCP, but also a reality check of what it's not, and making sure that people are clear on distinguishing the hype from reality, what it is that's genuinely exciting about it. So very much worth taking a look at these articles, looking through the marketplaces, and getting your own sense of what's going on in the MCP landscape. And so I know we covered a lot of material today. Hopefully it's all settling in. MCP hosts, clients, servers, the fact that MCP servers can be written in Python and launched with UVX, or in JavaScript through MPX. And they can also run in other ways as well, but those are the main two. The fact that there is Studio and SSE as the two transport mechanisms for MCP servers. And most importantly, the fact that the reason that MCP servers are so exciting is that it makes it so easy and frictionless to be hooking up your agent to many tools that have been written by people all over the world. And there are thousands of them to pick from. That's the so what. And in fact, next time, we're actually going to make our own MCP server and client so that we could contribute to this. I will see you then.